Our third type of calculation in this chapter will be calculation based on a chemical reaction. Therefore, in this episode, we introduce the basics of a chemical reaction. So how to represent a chemical reaction? Here you see a chemical reaction where you have formulas linked by an arrow. Well, all the substances formulas on the left of the arrow are called reactants. They are the substances that are reacting. All the formulas on the right of the arrow represents products. They are the substances that are produced from the reaction. Well, you also see numbers in front of each substance. Okay, this one, there is a number. When there is a number, the number is 1. You do not write 1 if it is 1. So what are they? They are called coefficients. They are used to balance a chemical reaction. What do you mean by saying balance a chemical reaction? Well, a chemical reaction doesn't damage any atoms, doesn't produce any new atoms. What it does is that it takes all the elements from the reactants, shuffle them around to reorganize them to make new substances. That's what they do. As a result, all the numbers present in the reactants must be the same as the ones in the products. Therefore, you need to add coefficients to make sure all atoms in the reactants are accounted for in the product. For example, in this case, on the left, with all the numbers filling in with all the coefficients, on the left, you have 6 hydrogen atoms. On the right, if you have no the coefficient here, you only have 2. You put a 3 here, 3 times 2, 6 hydrogens. Oxygen, there's 1 here, there's 6 here, altogether 7 oxygen atoms on the left. On the right, 2 times 2, that's 4, 3 times 1, that's 3, 4 plus 3, 7. Oxygen is accounted for. The last one's carbon. There are only 2 carbons on the left. There are 2 carbons on the right with the coefficient. Without the coefficient, it would have been only 1 carbon. Yep, that's balancing a chemical reaction. We say the above reaction is balanced. The coefficients in the chemical reaction specify the ratios among the substances. Be it a reactant or a product, it specifies the ratios among the substances, but the coefficients do not change the identities of the substances. When we use a chemical reaction to do calculation later on, you must use a balanced chemical reaction. So you must balance a chemical reaction before you use it to do calculations. The coefficients again tells you the ratio between any 2 substances in the reaction, but it has nothing to do with the amount of the substances used or a substance produced. Now let's go through the guidelines for balancing a chemical reaction. Okay, we know it is important because without balancing a chemical reaction, we cannot do any calculation. So let's go through the steps for balancing a chemical reaction. Here's the one we'll use as an example. Step number 1, examine the equation and pick one element to balance first. Number 2, then pick a second element to balance, and so on. Well, it didn't tell us anything. It just tells us to balance the equation one element after another. All right, here we go. Here is the 2 procedure we have to follow. How do we pick one element to balance it, then choose a second one to balance it again? All right, How do we pick an element to balance first? You find the molecule or formula that has the most atoms in it, and then choose the element that has the most atoms. All right, let's do that here. The formula that has the most elements or atoms, okay, that will be the one. Iron 3 oxide, Fe2O3. And in this formula, let's pick the one that has the most number of atoms. That would be oxygen. So let's balance oxygen now. On the left, you have 3 oxygens. On the right, you have 2 oxygen atoms. So we put a 2 here, put a 3 here. They are balanced. On each side now, you have 6 oxygen atoms. After that, since you put the 2 here already, so the iron, you got 4 now. On the right, you must have 4 ions. So let's balance the iron now. Put a 4 here. Iron is balanced. The only thing left is carbon. On the left, you have 1. On the right, you have 3. You put a 3 here. It is balanced. It's pretty simple, straightforward. That's true. However, sometimes it might be a little bit more complicated than this. Not a lot for this class. So let's practice another one by using the guideline. This reaction is a reaction between ethane and oxygen to produce carbon dioxide and water. So let's follow the guideline, find the formula that has the most atoms in it, and pick the one element that has the most atoms. It will be hydrogen in this case. Hydrogen. On the left got 6, on the right got 2. You put a 3 here. I'm going to put here in case I need to change them later on. Okay. In front of water right now is 3. Then naturally you're going to balance the carbon now, because you want this. If the hydrogen is balanced, then the coefficient here is set. You want to make sure the carbon is balanced on both sides. On the left you got 2. On the right, you have only 1. You put a 2 here, carbon is balanced. Now the only thing left is oxygen. On the left, you have 2. On the right, you have 4 plus 3, that's 7. How do we make this oxygen on the left? How do we make it into 7? Well, the only way you can do it is we put a fractional number 7 over 2. Okay, if that coefficient is 7 divided by 2, then 7 divided by 2 multiplied by 2, that's 7. Okay, so the coefficient so far, it looks like 1, 7 over 2, 2, 3. It is balanced. However, usually we do not use fractions as coefficients. So we try to eliminate the coefficient. How do we eliminate that one now? We multiply all the coefficients by 2. Now this one becomes 2, this one becomes 7, this one becomes 4, this one becomes 6. Now this one is balanced. On the left, you have 4 carbons. On the right, you got 4. On the left, you get 12 hydrogen atoms. On the right, you get 12 hydrogen atoms. On the left, you get 14 oxygen atoms. On the right, you got 8 plus 6, 14 oxygen atoms. It is balanced. Exercise: which of the following correctly balances the chemical reaction given below? This is the reaction given, not balanced. It is asking you which one of these 4 balances the chemical reaction above correctly. Well, this is a very interesting question. If you check all 4 answers, they are all balanced, but only one of them is correct. I say this is an interesting or good question because each incorrect answer represents a scenario that you have to pay attention to when you balance a chemical reaction. Number one, the reaction is balanced because a subscript 2 is added to a substance. All right, if you look at the original reaction on the left, it is missing an oxidant. All others are good. Okay, I'm just going to add an oxidant by changing the subscript. Well, you do not change any subscripts when you balance a chemical reaction, because when a subscript is changed, the substance is changed. It is not the original substance. You do not change the identity of the substance. All right, so that's why number one is not balanced correctly. Number two, if you look at it, everything is good. So number two is actually the correct answer. Number three, again, you count the atoms of everything. They're all good, all balanced. Well, usually when you balance a chemical reaction, you use whole numbers. You do not use fractional numbers. And that is why it is not correct. Number four, again, it is balanced. However, if you look at the coefficients, they are not in their simplest ratio. They have common factors. They have a common factor of 2. Divided by 2, this one becomes 2, this one becomes 5, this one becomes to 2, this one becomes to 1. It goes back to answer number 2. When balancing a chemical reaction, you must make sure all the coefficients are in their simplest ratio. There shouldn't be any common factors among them. Concept check. Which of the following are true concerning balanced chemical equations? Number one, the number of molecules is conserved. That is not correct. The number of each kind of atoms is conserved. The number of each kind of atoms will not change before and after reaction. That's why we have to balance it. The coefficients tell you how much of each substance you have. That's not true. It has nothing to do with the amount of any substances involved in the reaction. It only tells you the ratio, the molar ratio among the substances. Atoms are neither created nor destroyed. That is right. You do not change the kind of atoms, you just regroup them. The coefficients indicate the mass ratios of substances used. That's not right. They indicate the number of particles, ratio of the number of particles, or molar ratio, not the mass. The sum of the coefficients on the reactant side equals the sum of the coefficients on the product side. That's not right. That is basically the same as the first answer. That is not correct. So the only true answer is number 3. A quick review or a quick notice of this episode, then we're done. The number of atoms of each type of element must be the same on both sides of the reaction. Yes, we know that. Subscripts must not be changed to balance the equation. Yeah, we know that. We just discussed that. A balanced equation tells us the ratio of the number of molecules which react and are produced in the chemical reaction. We just talked about this. You either say the ratio of the number of molecules formulas or the molar ratio of the substances. Coefficients can be fractions, although they are usually given as lowest integer multiples. All right, do not use fractional numbers for coefficients in this class. Okay, when you're in the future higher level chemistry, it may happen, but right now, as beginners, let's keep using whole numbers as coefficients.